Hey guys, Spindle here, and today I am back with some more coding. We're going to be doing stuff for scope, and that's the hotkey, with scope and the variables. So this is a little bit more than last time. Last time we did, let's see, I have it up here. We basically just learned about printing to the console and the different things you can do with console and reading and writing. So not a whole lot from there. So this is kind of a step up from that. So we're going to start with different variables, or variable types I should say. So one of the first ones, the int, doesn't matter a whole lot. We'll get into this part a little bit later. The public is the part that we're going to be looking at, like that kind of spot. So public int equals 10. Right now the value doesn't matter too much. Okay, you guys can't see my mouse. So basically, so the int allows for basically any class to access the variable. So this would include things like changing it. This would include accessing it just to, put it as a variable, like using it like how we would do from last video where we took like the read line from the console, put it into a variable, then used it elsewhere. You could have this public variable here, and then I can come over into my scope class and I could use it here as well. So you have that level, and if I change it over here, it will change over here. So that's public. That's the very open, it's the most open sort of visibility that you can get. All of the ones that we will be going over for also apply to functions, which once we get into inheritance, we'll talk about the difference between functions and methods a bit. So the next one is private. So for private, it's a little bit different. Private, it can only be used in that class. So no other class has access. They can't even see if this variable exists. So if I have private int over here, there is nothing that I can type over here that can see private int. It won't exist. The last one we will go over is protected. So protected int, we're not going to be touching on this one too much right now. This is once you get more into inheritance. So the easiest way to describe it, do it right here, is it can only be used in its class and subclasses. So subclasses would be, the easiest way to describe that is children. So you have, and this is actual terminology for coding, I'm not randomly making things up. So you would have a parent class, and then you would have a child class, and they can have multiple children. You can have children of the children, etc., etc. That's where it gets its name, inheritance. And basically and the only classes that would be able to use it is this one, and then anything below it in the inheritance chart. Now, if you had, let's say, hold up, we can just, it's going to give us errors, but we can work around that. Oh, crap. Nope. Autocomplete, go away. All right, so let's say that child class has a protected variable, right? Like this one down here. So the flow is this parent would be the parent of these two children. This single child is the parent of this child. If I have a protected variable in this child, none of the above classes can then use it. It's only if there is then a child below that child. Then this child would be able to use that protected class as well. So it can get a little bit tricky when it comes to inheritance, but we'll go over that more once we get to doing actual inheritance with objects and more classes. So the next part is we're going to get into the scope of variables. So we're going to make a couple of different variables. So first up, we're going to do public short, where the name doesn't matter too much, neither does the value. So visibility, oops, I can't spell, ability type. So the visibility type would be public in this case. And then this is a public short. So 16-bit whole number. So the short is basically the type of the variable. Public is the visibility of the variable. And then this is just the name, which doesn't matter too much. So this is the order. Let's see if we can't format this a little bit. Yeah, there you go. That's a little bit better. So just for the first one, I'll do this. So you got visibility, visibility, type, type, name, name. So that's kind of how you know what everything is. Now, as for this, bits, if you guys don't know binary, the max, or the lowest number is, oh god, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16. So for this, you have lowest number and you have highest number. I'm not going to go over signing because that confuses me sometimes. But basically, you have minimum and maximum within this. Each, if it's binary, so it's 2 to the 16th. I personally don't know that off the top of my head. If somebody else does, by all means. But so that's the essentially min and maximum that you can do is anything within the 16-bit range for signed numbers. And signed just means positive or negative. So like that's adding a sign, leaving it without the negative. That's technically a sign because it's positive. All right, next one. We are going to do public int test ints equals 0. And this one again, I'm gonna skip doing this part because I pray that you guys can see that it's gonna be the same exact thing all the way down. So public int, that's 32-bit whole number. So it's the same as the 16, except can hold a lot more. Next one up is public long test longs. Now for longs, you need to add in the case of C#, you got to add a capital L. Some it's lowercase l, some it doesn't matter. This, I believe for short, it's an S. Nope. Capital S? No. Okay. I think that there's something for C# for shorts, but I forget. And this one, public long 64-bit whole number. And we'll add this just so that you guys can see that. But the reasoning for doing different sizes is if you get into something for using memory or for speed, it typically is faster if you're not using excess space. So having it process oops, I forgot parentheses there. Having a process 64-bit number, yeah, it's going to take a little bit longer than doing a 16 if it's only holding the number 1. Alright, so next up, we go to floats, floats and double, which are probably two of my least favorites because they annoy me. So we're going to do public float, test floats. Now for floats, you got to add an F to say that it's a floating point number. And float, it is a 32-bit decimal. So this is how you do decimals with single precision of 6 to 7 digits. So any of you that do chemistry, think sig figs for precision. And then note how it needs the F at the end. So same concept as all the others. All these can deal with positives and negatives. Next one is double. And for this one, I'm sure that you guys can guess at this point, you gotta add a D at the end to specify that it's a double. Public double. This one's a 64-bit decimal, and hence the name, double precision. I can't spell. Alright, so, almost forgot. So this will just have a more precise decimal, and it can hold a much larger one. Alright, next up is we get into stuff for strings. And of course, it really wants me to do variables that we won't be making. Thank you, auto. Suggest. Alright. So this one's going to be string. And for strings, it is marked by the double quotation marks. I'll show you what single quotation marks does in just a second. So for strings, you can do almost infinite number of characters in it. You could write a full book in one set of the quotation marks. So again, use the double quotes. If you use the single quotes, you get something called, I don't know how others pronounce it. I pronounce it as char. Some I think do car. I don't know. But how these work is it can only contain, and you use the single quotes, a single letter, number, or as you guys saw in the suggestions, if I can get that back, let's see. This is, oh god, what is it? Bitcode, Unicode, something like that. I think that's Unicode for this. /0, I think that's space, or it's an empty slot. Yeah, so there are many things you can do with it. We'll just be throwing a in there for now. So it can hold just about any character, or you can do, oh, let's see, what is it? I think that you can, nope. All right, never mind. We're just gonna leave it like that. I think that you gotta do, actually, let's see if I can remember it. Maybe? Okay. I don't know it for C#. But you can do it with using Unicode encoding, but I don't know that off the top of my head for this. So again, just remember the use of the single quotes, not the double quotes. And next up we have Booleans. So Booleans take only true or false. You cannot do anything else with them. I will show one thing that you can do, which we will get to towards the end, or one of the other sections going down, and I'll show you what else you can do with this. It doesn't just have to be putting in true or false. You can actually do some Boolean expressions with it, and the output, just the final result in the variable, has to be true or false. Or null. You can also put null in it. There's not that much, or at least some languages you can. Can you do it for this? Okay, no. So yeah, true or false. I think Java or something lets you put in null, but that's not all languages. Where was I? Ah, yes. So it can only contain true or false, and it is used for logic. Next up, so this one is a little bit different from the others. Everything else here has been of a variable type that's, logical. This one we're going to be using a class. So as you guys can see here, where we did stuff before, internal class variables, well, we can take that and we can actually use it in this code. So what we can do is we can do public name of the class, and then typically the convention is to do it all in lowercase. That's just to kind of variables. You do camel case, as seen here. You do lowercase for a word, and then you do uppercase for the second word, and then it would be uppercase for the third, so on, so forth. For classes, it's basically the same, except the first word is also capitalized. So typically the convention is just then lowercase the variable that's for it. Now, the way to get access to it is something called C# is object oriented, so you have to make it an object. So doing new and then the class, you're essentially making a new object instance of the class, and then you can use the stuff that's in the class as if you were within it. So that's how that works. New is the keyword to say that you're making a new object. And this one I did a lot of writing for. Okay. So public variables, class we made. Also, there are, for a lot of these, if we do public, a lot of the ones that we had here do have an actual class. The difference between the two, if I'm correct, there's something to do with wrapping, which we're not going to get into. But each do have their own uses. Class we made, and it equals a new instance or object of the class. We will go... okay. So we will go over more of this when we discuss classes, and some of it will make sense also when we do inheritance. Discuss classes, because it's just not, it's a long topic kind of. So we'll go over that eventually. Alright, next up, we will actually be testing some of these variables to see kind of what they do. So, sorry guys, don't know where that yawn came from. So first, what we're going to do is we are going to variables. We want it to do the variable. Why is it doing that? You should not be... Huh. I don't know why it's trying to do... Variables is not null here. Oh, I have to... Okay, I see. I had to remove the static. We'll go over what static does later, but oh, why is that there? In order for this to work, we have to remove the static in the main method. That's why. Static always gets me. Okay. So now what we can do is, as you guys can see, we have public int as a variable that we can use, and we have public int. Or, sorry, we have public int, and that's it. It's weird how it gives it to you both times. The reason for that is, again, protected int we can't use because it's only for the parent class and its subclasses. This class does not inherit variables, and private int can only be used in this class. So we cannot see it over here. And so we're going to use public int, and we're just going to get it to skip a line. So \n, that's just to make it go another line. So like for up here in our char, we could do \n, that is acceptable. And then we could put test chars there, and it would skip a line. But we're going to put it back to A for now. Alright. Now, one thing that we're going to do is variables.public int, and we are going to do plus equals 1. So what the plus equals does is it is the exact same as doing variables.public int equals variables.public int plus 1. These two are the same exact thing. I prefer to use the plus equals. Personal preference. Another way to do it for doing just plus 1 is just doing plus plus. So all three of these do the same exact thing. There's no difference. The only difference is this one can only be done, can only increment by 1. The others, you can just switch out the one with other numbers. Class.variable. It can also be a function. So this is just showing how to pull something from the variables class. We could put a public function in here, and then we could call it in here. We're not doing that in this video. Alright. So then if we do console, oops, I can't spell to save my life. And we are going to print out this. Also, when you're doing, even if it's for one character, you can technically use the double quotes, as a string can hold anywhere from 0 characters to almost infinite. A char, it's literally, you can do 1. You can't even do empty, really. You have to have at least 1. Alright, so we're going to try running this. Please be set to... Oops. Debug profile doesn't exist. Oh, crap. Okay. I forgot to do this. Where is it? Is this? Oh, why do I forget where everything is? Clean solution, no. Okay, well, I'll be right back. I just gotta fix this really quick. Alright, so there was a simple fix. Oops, I did that again. So all that I did was I put the static back to the main because it does, in order to properly run, it has to have a static main method. So in order to solve the fact that earlier there was an issue because we can see here, object reference is required for the non-static method or property. The way that we're fixing that right now is we're just adding static to it. That is fine for what we're doing. So if we run this, you guys can see as visible, we start off with it being 10, we increment by 1, we get 11. And that will be the same if you use any 3 of these. Alright, next up we have, let's see. Okay, so I'm going to copy paste this because it's just a lot of typing. And I'm just going to show you a couple things here. So if I uncomment this, it's going to give me this red line. Because of its protection level, I can't use private int. It, as far as this class is concerned, it just doesn't exist. Same with protected. Protected to this class doesn't exist. So that's all that those are. Next, that's just... Okay. So, we have, for the next part, we're going to do test ints minus equals 1. Is that not a... Hello? Oh. Okay. We're gonna have to make all these static now. That's my bad. Don't worry too much about static. I'll go over that in a video. Okay, So now that we made all those static, now we can use them down here. Minus equals 1, and we're going to do test ints minus minus. So same as test ints equals test ints minus 1. All of these are the same, so same as doing the plus 1. Next, we are going to do test ints times equals 1. Same as test ints equals test ints times 1. It's kind of nice that there's a little bit of a theme going on. Makes it a little bit easier. So we can also do it with division. Test ints equals test ints divided by 1. I don't know why I'm adding the semicolons here. They're not really that needed. Okay. Next up, some of you may not know this one. This is mostly used for coding, not really much in math, but modulo. Test ints module 1, or modulo. That's remainder. So same as test ints. Oh god, nope, that's wrong. Because I forgot this. So what this does is it will run test ints divided by 1, and it's going to find the remainder. So modulo slash remainder. Here's an example. 10 divided by 7 is 1 with a remainder of 3. We're going to space this out, makes it a little bit more legible. So 10 modulo 7 is 3. Alright, next up is doing some stuff with booleans. So if we do bool and equals true, so the way that you represent and like the and operation is two and symbols false. Alright, now I got a couple of notes here. So for this, the warnings, they can just be ignored. The reason why is we don't use them. Can't be ignored. The warning is because we aren't using it. Alright. So we have a Boolean operator. The two and or at symbols. Is it at? No, these ones are and. I'm an idiot. Oops. Is the key for and. Both sides must be true to get an output of true. So for this scenario, this will be false. True and true would be true. Next up is we are going to do or. So if we have true, or is using like the two straight lines. So if we have true or false, will be true. False or false would be false. and it doesn't matter the order in which the true is. If it's present, it'll be considered true. This is the Boolean operator for OR. One side needs to be true for the output to be true. So as I was saying up here with when we were going over Booleans, as you guys can see, this is considered the final output in a sense. Down here we did a Boolean operation, which if you solve it gives us a Boolean which can then be used in the variable. Now for Boolean operations, it doesn't only need to have Booleans. So I could do, we are not doing XOR. So if we have, we'll just call it math, I don't know. So if we have true, actually no, wait, let's do this. So for the math, let's do, I don't know. What's testins? I have no idea what testins is going to equate to after this, so let's use, we're going to switch up the value of test shorts. We're going to call test shorts 1, test shorts oh, did I just call it short? Okay, well, we'll fix that. There we go. So you can even use these operators. So you can use less than, greater than, less than, equal to, greater than, equal to, and then that's it. I completely forgot about those when I was writing my template for this. So these are all acceptable for when you're doing Boolean operations. So for this case, you're using math because, you know, you're checking to see if test shorts is less than 1. If it is, then the Boolean will hold the value of true. If it's not, then it will hold the value of false. This is a very simple one. You can make them super complex. We'll get more into doing stuff such as this once we get into if statements and for loops. So I'm gonna just copy paste this part, I think. I'll read this to you guys, but I'm gonna save myself the trouble and time of typing all this out. So we are going to do stuff for scope. So the scope is basically the different areas that a variable can go. And I'll show you guys that. So we're going to start by making a variable inside of our main method. We're going to call it test. We're going to have it set equal to 0. So console.writeLine, we're going to print test. We are going to now run this. As you guys can see, test is equal to 0. Oops. Please stop breaking everything, Quinn. So, as you guys can see, test is equal to 0. Now, if we continue, we're going to make a method down here. Actually, I'm going to pause this. I got to go really quick. Sorry about that, guys. I had to go to a class. It was not that much fun. Biolab. Ugh. Alright, so for this one, let's see, where am I? That is our main. Yes, okay, that's why it looked weird. It's like my curly braces are indented wrong. Alright, so here we're going to make a new function. I'm going to call it add1. All that we're going to be doing is just incrementing a number by 1. So super simple. So how this works is we have the visibility, we have its return value, which for this one it's void. If we put int here, then we would return a number of some type, but we don't need to return anything, so we're just going to have it be void. Then we have the name, and then this is parameters, so we're going to pass in an int, and we're going to call that int value. The name for our purposes doesn't matter too much. Alright, so what we're going to do is we're going to do oh god, I can't spell. Add1 test. So, oh god, why are you not? Reference is required for the non-static field, method, or property. Scope.add1int. It's because I gotta call it static. Public static void. There you go. Happy now? Thank you, computer. Alright, so now what that should do is if we print right line test, oops, and let's run this. Alright, so this is how it's supposed to look. Alright, so the first one, we get 0. That's from this right line. And actually, you know what? I'll prove it to you guys. We're going to do, this is called concatenation. You do a string, and then you use a plus sign, or you could actually use, I believe it's in this language too, a comma. The comma adds a space, the plus sign does not. But this is called concatenation. It combines a string and really anything else. So you can have variables, you could have another string, but this is called concatenation. We'll go over that more in depth later, but just to help you guys see, as you guys can see, we have 0, and then we are supposed to add 1 to it, but we still get 0. Now, the reasoning for that is if you scroll up, you have all of these variables here are clearly present and available for use in our main method. And we could even come down here and we can use test ints or test bools or any of those in here. However, our variable test was made in main. So we cannot use test down here. As you guys will see, test does not come up. So one of the easier ways to define scope is within its own curly braces. So test can only be used currently within the main method. If we moved it up here, then it would be within these curly braces, and it could be used in all this area. Another thing to consider is when you pass a variable in as a parameter, it will only change there. So we have value is becoming test. We did value plus plus. It did not change test. The reason for that is value is a copy of the variable test. I do not know how to do it in this. However, if we pulled up the registers for memory location of variables, you would be able to see that value and test, they're not entirely the same. So whenever you pass in a value as a parameter, if you would like the value that it computes in the end, you need to either return it. So for example, we did int, and then we could do value. This would return the value, and then we could use that elsewhere. If you only do this, then the value will be computed and then lost. a way to get around using return is you could make a global variable. So technically these aren't entirely global, as if we made another class, these wouldn't be visible in it. But I don't believe that you can move them up. We'll just double check. Okay, yeah. So you cannot put them up here. So these are the global variables that you can use. So if you would like to get away from using the return, you can just store it into a global variable and have some that are defined for this. However, it is typically used where you'll use return, or if it just so happens you might use a global variable, but a lot of times you will be using return for things. It just makes more sense for some stuff. So that is how that works. Now, to show you guys, if we did public void add one global, and yes, I know that I gotta add the static. I'll get to that in just a sec. Static. So if we do console, oh god, no. Why can't I spell? Somebody please teach me how to spell. Oh my lord. All right, right line. We're just gonna say ints equals plus test ints. So that's gonna print that out. I'm gonna copy this. Now, if I do add one global, and we print again, now you guys will see int starts off as 0 and then it becomes 1. The reasoning for this is because when we compute this value, it is the same as doing test ints equals test ints plus 1. These two are the same things. So what we're doing is we're taking the global variable and we are setting it equal to the global variable plus 1. It's the same exact thing, just a little bit different. So because the variable is accessible from here, we can use it down here. Same, it's in the same bounds of the curly braces, and we can just add 1 to it. So that's how scope works. This is a very basic scale. The way to do it for variables is in their parentheses. Value can only be used within these parentheses. Even though we didn't declare it in the parentheses, it was declared in the parameter. So anything that you declare in the parameters is only used within those parentheses as well. So that's all that I got for you guys for this one. Hope you guys did enjoy, and I'll see you guys in the next one. Bye.